Okay, so let's understand another vectorization technique, which is called TF-IDF. TF stands for term frequency, and IDF stands for inverse document frequency. Okay, I'll explain what all of this is in a minute. So first, I'll explain what term frequency is. All right. So, what is term frequency? Let's say I have a document corpus, okay, of reviews, R1, R2, R3, R4, all the way to Rn. And review one has some words. They're identified by word 1, word 2, word 3, word 4, word 5. The review 2 is identified by word 1, word 2, word 3, word 2, word 5, word 6, right? It doesn't have word 4. So, how do you calculate term frequency? Term frequency is basically calculated by, look, you calculate term frequency and inverse document frequency for each word, okay? So term frequency, the formula is given by number of times the word occurs in a review, number of times the word occurs in some review Ri upon total number of words in review Ri, okay? Word, let's say some word Wj, okay? So let's say term frequency of word 2 in review 2 would be the number of times word 2 occurs in review 2, which is twice. This is word 2 here, this is word 2 here, upon total number of words, which is 6. Okay, so this is the term frequency for word 2, review 2. So how this works is, again, you create your feature space where you take every word as a feature in your data set. So you have word 1 as one feature, word 2 as one feature, word 3 as one feature, and so on and so forth. So if I'm calculating the vector for review 2, what I would do is I would put the term frequency over here, which is 2 by 6. Okay, that's how you calculate the term frequency. Similarly, I'll calculate the term frequency for W3, and I'll put the particular value here. Since W4 does not occur in review 2, W4 will get a value 0. Okay, so that's how it works. So now that we have understood term frequency, let's also understand what inverse document frequency is. Inverse document frequency. Okay. Now, inverse document frequency is basically log of the total number of reviews in your data set. Okay, so over here I have n reviews, right? Over here I have n reviews. So the total number of documents or the total number of reviews in the data set, total number of reviews in the dataset upon the total number of reviews in which word J occurs. Okay. So now if I have to calculate the inverse document frequency of W2, okay, in a document corpus D, okay, so all of these reviews are, I'm going to call them D, okay. All of these reviews come under a all of these reviews come under a document D. Okay, so if I have to calculate the inverse document frequency of the word W2 in the document D, this would be given by log of the total number of reviews in the data set. I'll make this capital N, okay? The total number of views in the data set are N, whole upon the total number of reviews in which Wj or W2 occurs, okay? In this case, Wj is W2, right? So over here, we can see that W2 occurs in two reviews. So it occurs in the first one, it occurs in the second one. And it can occur in other reviews as well. So I'll consider the total number of reviews in which W2 occurs as small n. Okay, this is small n. So this is your inverse document frequency. Now, so this is inverse document frequency and this is term frequency, right? So it's easy to note here that your small n will always be less than capital N, right? Because the total number of reviews in which the word W2 occurs can never exceed the total number of reviews in the document. So your small n will always be less than capital N, which means that, you know, n by n will tend to 0 as the small n increases, right? Which means that log of n by n would also tend to 0. Log of n by n would also tend to 0 because log is the monotonic function, correct? So how does TF-IDF work? When I find the term frequency of W2 in some review R2, and I find the inverse document frequency of W2 in some document D, I ultimately multiply it. Okay, so when I'm calculating the feature space of this review R2, I'll multiply it by the inverse document frequency of W2. Okay, so you can, if you observe carefully, you can observe a relationship here. Term frequency increases if the word is very common, right? And inverse document frequency decreases if the word is very common. Similarly, inverse document frequency increases if the word is very rare. And term frequency decreases if the word is very rare, right? In fact, a lot of times it might just be 0. So that is what term frequency and inverse document frequency do. That is what inverse document frequency does, actually, not term frequency. Inverse document frequency penalizes for, penalizes the feature for words that occur very common, because it's usually assumed that a lot of relationship, a lot of information is hidden in words that are not very common. Let's say I have a word like a not so common word like arduous. Okay, this word is not very common, and that's why we assume, and it's generally also seen in English, that the words that aren't very commonly used have a lot of information in them. So I want to uh, you know penalize words that occur very commonly, and I want to also try and express the value of words that are not very common. And that's why I multiply term frequency with inverse document frequency. It sort of puts all the words on a level playing field. I don't want one word being subdued just because it doesn't occur very often. Okay, it puts all the words on a level playing field, right? So that's how term frequency and inverse document frequency works. And yeah, so another thing to note here is that even term TF-IDF is not immune. It's not. It does not. It does not. Wait, I'll just write it again. Does not express the semantic relationship. Okay. Even TF-IDF does not help us do that. To express the semantic relationship, there's something called word-to-vec, which I will cover in the next video. Does not express the semantic uh, relationship, right? Now you might have a question. The question that you might have is, why do I take the log in IDF, right? So as to why I take the log in IDF, there's a relationship, there's a law called the ZIPF's law, okay, ZIPF, right? So what this states is that, if I look at English, the histogram of words used in the English language is somewhat like this, okay? This is the frequency, and these are the words, okay? So some words like a, and, the, they occur very frequently in English, okay? If you take then all of the Wikipedia pages, you tokenize them, you get all the words, the count of all the words in the pages, you would see words like a, and, the, a, and, the, and all these words occur very frequently, right? And words like arduous don't occur very frequently. They are particularly less common, right? And if you see the shape of this graph, it looks something like the power law distribution, correct? And we know that if you see something like the power law distribution, it's a good idea to apply the log transform on it. So I take all the random variables I take log of those random variables. So this gives me a graph, something like this. It gives me sort of like a linear relationship, right? So that's more helpful in trying to model our data set. So this is one reason that we put sorry, this is one argument that we put forward as to why we need log. There are other arguments as well, although I'm not very sure. I know this one. I know Zipf's law. I don't know the others. But if you want, you can just check Google for that. So this is one reason why we use the log function in IDF, right? So in the next video, I'll cover word2vec.